Hello everyone, good evening. So here we shall solve some more JEE Mains previous year questions on the chapter circular motion. So any doubts if you have in any steps, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. Also in any other chapter of physics, if you have more difficulty, then please mention the name of that chapter also in the comments section so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions on every chapter of physics will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So we shall start from the very first question onwards. It is told that a clock has 75 centimeter, 60 centimeter long hand, long second hand and minute hand respectively. In 30 minutes duration, the tip of second hand will travel x distance more than the tip of the minute hand. The value of x in meter is nearly. So now the rule is the tip of the second hand makes one revolution makes one complete revolution in 1 minute or in 60 seconds. And the tip of the minute hand makes one revolution in 60 minutes. Therefore, in 30 minutes, the minute hand will make half revolution. And the second hand will make 30 revolutions. Therefore, the distance covered by the tip of the minute hand, the distance covered by the tip of the minute hand, that will be equal to 2 pi r into 30. It is 2 pi is 3.14. It is told to take pi as 3.14. Pi r is 75 centimeters. Since 75 centimeter is the length of the second hand, into 75 into 30. So this much centimeter it will cover. Okay, so this will be 75 into 2 is 150. Instead of 45, 4500 into 3.14. So 4500 pi centimeter it will cover. Then the distance covered by the tip of the, this is the distance covered by the tip of the second hand. And the distance covered by tip of the minute hand, that will be distance covered by the tip of the minute hand. So that will be equal to 2 pi r dash, let's say, into half. R dash is the radius of the minute hand, that is 60 centimeters. So that will be pi r dash. So that will be 3.14, which is pi into r dash. R dash is 60. So it is 60 pi centimeter. Now, therefore, it is told that the tip of the second hand will travel x distance more than the tip of the minute hand, then the value of x is. So therefore x will be equal to 4500 pi minus 60 pi, this much centimeter. So this will be equal to 3.14, that is pi, into 4500 minus 60. So this will be 0 is 4 is 4440 into 3.14 centimeters. So this will be equal to, so x is in m- meters. So as we know, 100 centimeter equal to 1 meter. So this will be this divided by 100, this much m- meter we have to find. So this will be 44.4 into 3.14 meters. So this will be approximately 3 4s are 12, 3 4s are 12, 13, 3 4s are 12, 123.2. It's slightly more than that. Okay. Actually 44.4 into 3.14. So this will be approximately 139.4. So it means that option C is the correct answer. Then here it is told a car of 800 kg is taking turn on a banked road. So there we have a banked road. Then one car is taking a turn. A car has to take a turn on this banked road. The mass of the car is 800 kg and the radius of the banked road, the radius that is 300 meters, and angle of banking is 30 degrees, theta equal to 30 degrees. The coefficient of static friction is 0.2. The coefficient of static friction, that is 0.2, mu s, that is 0.2. Then the maximum speed with which the car can negotiate the turn safely is. So maximum speed, so the friction will act down the incline friction, which is equal to mu s into n, and this is the normal reaction force. This is mg, so this will be mg cos theta. This way it will be mg sin theta. Okay, no, so we don't have to tell this. So we can take this angle, this is 90 degree. Now this is 60 degree. So this is also will be 30 degree. This will be also angle theta. This is 90 minus theta. This will be theta. So this will be n cos theta. This will be n sin theta. So from here you can say n cos theta, that will be equal to mg. And sorry, this is friction. And friction also this way, this will be 90 minus theta. So this will be angle theta only. So this will be plus mu s n into cos theta. And this way it will be mu s n into sin theta. So n cos theta will be equal to mg plus mu n sin theta. And n sin theta plus mu s n cos theta, that will be equal to mv square by r. So this v we have to find out. So then from here we can see that this n cos theta minus mu n sin theta, that will be equal to mg. Now if we divide the first equation divided by second equation, then we will get v square by rg, that is equal to That will be equal to this n will get cancelled. So this will be sine theta plus mu s cos theta by cos theta minus mu s cos theta. No, mu s sine theta. So this we can write, this will be, if we divide by cos theta, then this will be tan theta plus mu s by 1 minus mu s tan theta. So therefore V max, the maximum safe speed we have to find. Maximum safe speed, that will be equal to root over rg into tan theta plus mu s divided by 1 minus mu s tan theta. Now from here, tan 30 degree equals to 1 by root 3. 1 by root 3 means it is root 3 by 3 again, right? Root 3 is 1.73, it is told. 1.73 by 3, that is 3. 6 18, 3 5 is 15, 23, 3 7 is 21, 3 8 is 24. So it is approximately 0.58. So this will be equal to root over r, the radius is 300 meter, g that is 10, and tan theta is 0.58 plus mu s is 0.2 divided by 1 minus mu s, that is 0.2 into tan theta, that is 0.58. So this will be equal to 3000 into 0.678 by 1 minus 0.2 into 0.58. It is 0.116. So this will be square root of this 30 into 78 by 1 minus 0.116. Is 0.884. This will be 30 into 78, that is 2340 divided by 0.884, then it's square root. So this will be 2340 divided by 0.884. So this is approximately this is 51.45 meter per second. 51.4 meter per second. So option A is the correct answer. Then here it is told a man carrying a monkey on his shoulder does cycling smoothly on a railway track of radius 9 meter. A man carrying a monkey on his shoulder does cycling smoothly on a circular track. He does cycling smoothly on a circular track of radius 9 meter and completes 120 revolutions. It should be 120 revolutions in 3 minutes. The magnitude of centripetal acceleration of the monkey is. So the magnitude of centripetal acceleration, that will be equal to v square by r, obviously, or we can tell it is omega square r. V is equal to r omega. Now omega is actually, we can write this is 2 pi by t, the time period of revolution, 2 pi by t whole square into r. This is 4 pi square by t square into r. Now the time period of revolution, that is 120 revolutions in 3 minutes. So 120 revolutions is carried out in 3 into 60 seconds. So one revolution will be carried out in 3 into 60 by 120 seconds. So in 3 by 2 seconds, that is 1.5 seconds. So in 3 by 2 seconds, one revolution will be carried out. So therefore the time period is 3 by 2 seconds. So this will be 4 pi square by 3 square 9 by 4 into r. R is 9 meters. So 9 will cancel. So it is 16 pi square meter per second square. 16 pi square meter per second square is the centripetal acceleration of the monkey. So option B is the correct answer. Yep. So here centripetal acceleration. So centripetal acceleration will act on every object. Okay. So centripetal acceleration actually it will act on the monkey also and on the cyclist also and on the cyclist and on the cycle also. So centripetal acceleration will act on every object which is moving in a circular path. Then it is told that a cyclist starts from the point P of a circular ground of radius 2 kilometer. Radius is 2 kilometer and travels along its circumference to the point S. Starts from the point P of a circular ground of radius 2 kilometer and travels along its circumference to the point S. The displacement of the cyclist is. So we have to find the displacement which is P2S, this length. So the length PS that will be equal to 2 root 2 kilometer. 2 root 2 kilometers, since why it will be square root of 2 square plus 2 square. That is root over 8 kilometers. So option A is the correct answer. And here it is told a ball of mass 0.5 kg is attached to a string. A ball of mass 0.5 kg is attached to a string of length 50 centimeter, means it is 0.5 meter. 0.5 meter. The ball is rotated on a horizontal circular path about its vertical axis. So it is moving in a circle, horizontal circle about its vertical axis. It means it is somewhat like this. It is moving in a horizontal circle. It's moving in a horizontal circle. The maximum tension that the string can bear is 400 Newton. The maximum possible value of angular velocity of the ball in radian per second is. So the maximum angular velocity that we have to find out. So maximum angular velocity will come when the maximum tension will act. So this is T, let's say. So then if the angle the string makes with the vertical, let's say that is theta. So this is T, so this is T, this will be also theta. This will be T cos theta, this will be T sin theta. And this way it will be mg obviously. So T cos theta will be equal to mg and T sin theta will be equal to mv square by r. mv square by r. R is the, now r is how much? R is the radius of the circular path, which is r will be equal to L sin theta obviously. R is equal to L sin theta. Okay, so now from here we can see that tan theta T max. Okay. So from here T square will be equal to m into v square by r whole square plus g square. Since why if we square both and add, if we square both and add them, then we will get this. We can also write this as omega square r, be m omega square r. So this you can write omega square r whole square. And let's say the r, if I tell it is, okay, so r is L sine theta. Okay, from here only we can find. So T sine theta that is coming, that is equal to m omega square r. R is L sine theta. So sine theta will cancel out. Then it means that omega square is coming T by ml. So it means omega will be equal to root over T by ml. It means omega will be root over T. T is tension, that is maximum tension 400 uh, by m, mass is 0.5, and L is also 0.5 meter. So this will be so the root will be 20 by 0.5, which will be 40 radian per second. So option C is the correct answer. And here it is told a particle moving in a circle of radius r with uniform speed. A particle is moving in a circle of radius r, that is of radius r, with a uniform speed v, takes time t to complete one revolution. So that time period is t. If this particle is projected with the same speed at an angle theta with the horizontal, let's say it is moving with the velocity u to the horizontal, the maximum height attained by it is equal to 4r. The maximum height that is equal to 4r. The angle of pro projection theta is then given by this theta we have to find out. So the maximum height, as you know, that is equal to u square sine square theta by 2g. So therefore, and from here t, the time period of revolution. So u, it is a uniform speed, so I can say it is equal to the average speed also, which is equal to 2 pi r by t, d equal to 2 pi r by t. Now therefore sine square theta that is equal to 2g h max, which is equal to 2r, no 4r. So 2g into 4r divided by u square. So therefore sine square theta that is equal to 8rg by u square, which is 4 pi square r square by t square. Okay, 4 2 is 8, so r will cancel. So it means sine square theta is coming as 2g t square by pi square r. So it means sine theta will come 2g t square by pi square r power half, means the square root of this 2g t square by pi square r power half. So therefore theta will be equal to sine inverse of 2g t square by pi square r power half. 2g t square by pi square r power half. So it means that option A is the correct answer. Then here it is told a coin is placed on a disc. A coin is placed on a disc. The coefficient of friction in between the coin and the disc is mu. If the distance of the coin from the center of the disc is r, the maximum angular velocity which can be given to the disc so that the coin does not slip away is okay. So there is a disc. This is the disc. So here they have kept one coin. Here they have kept one coin. This is the coin which they have kept at a distance, which they have kept at a distance r from the center of the disk. And the coefficient of friction is mu. Then we have to find with what velocity it can rotate, with what maximum angular velocity it can be given to the disk such that the coin does not slip away. So here the friction is acting, the friction is providing the necessary centripetal force. The mass of the coin is m. So mg is acting downwards and normal reaction is acting. So then mv square by r, that is the friction, that is, no, it is equal to actually m omega square r. That is, friction is providing the necessary centripetal force. And the friction, that should be less than or equal to the maximum static friction. Then only it will, then only the coin will not slip. Then only the coin will not slip away from the disk. Okay, so therefore the friction, that is m omega square r, that should be less than or equal to the maximum static friction, which is mu into n. Now n is equal to mg, the normal reaction equal to mg. So therefore m omega square r, that should be less than or equal to mu mg. So m and m will cancel out. So therefore omega square, that should be less than mu g by r. So it means omega should be less than or equal to square root of mu g by r. So therefore the maximum angular velocity that can be given to the disk, that will be square root of mu g by r. So option B is the correct answer. Okay, then here it is told a stone of mass m, of mass 900 gram, is tied to a string and moved in a vertical circle. It is moved in a vertical circle of radius 1 meter, making 10 revolutions per minute, 10 rpm. So this is the angular speed. The tension in the string when the stone is at the lowest point is the tension in the string when the stone is at the lowest point is. So when the stone is at the lowest point, in a vertical circle, so the angular velocity is remaining constant. So here mg is acting and here tension is acting. So you can say T minus mg, here the velocity will be equal to r omega. So T minus mg, that is equal to the centripetal force, which is m omega square r. T minus mg, that is equal to m omega square r. So the tension will be equal to mg plus m omega square r. So this will be equal to mg. Mass m is given as 0.9 kg and g is 9.8 meter per second square, and pi square we can take it as 9.8 also. So omega is 10 rpm, so 10 revolutions in 1 minute. So therefore it is in 60 seconds. So 10 revolutions in 60 seconds. So therefore 1 revolution in 6 seconds. So therefore the time period of revolution that is 6 seconds. So therefore omega will be equal to 2 pi by t, 2 pi by 6 is equal to pi by 3. So this will be m into g. G is 9.8. Okay, so therefore the tension that is equal to m, which is 0.9 into g, that is 9.8, plus m, that is 0.9 plus into omega square, so pi by 3 whole square into r. R is 1 meter, so this is 1 square. So this will be 0.9 into 9.8 plus 0.9 by 9, this is a 9 into pi square is also 9.8. So this will be 0.1. So this will be 9.8 into 0.9 plus 0.1. So this is equal to 1. So this is 9.8 Newton. So 9.8 Newton will be the tension in the string when the stone is at the lowest point. Option C is the correct answer. Then here it is told if the radius of curvature of the path of two particles of same mass are in the ratio 3 is to 4. The radius of curvature of the path of two particles of same mass are in the ratio 3 is to 4. Okay, then in order to have constant centripetal force, the velocities will be in the ratio. Now centripetal force that is given as mv square by r, mv square by r. So now the force, this centripetal force has to be constant. It means that, and they are having the same mass also. So mass is also same. So it means v square by r, that should be constant. So it means that v square will be proportional to r, or it means that v will be proportional to root r. So it means that v1 by v2 means the ratio of their velocities will be the square root of the ratio of their radius of curvatures. So that will be equal to square root of 3 by 4. Since why r1 by r2 that is given as 3 by 4. This is given in the question. So therefore v1 by v2 that will be equal to root 3 by 2. So therefore v1 is to v2 is equal to root 3 is to 2. So option C is the correct answer. Then here it is told a train is moving with a speed u equal to 12 meter per second on rails which are 1.5 meter apart to negotiate a curve of radius 400 meter. The height by which the outer rail should be raised with respect to the inner rail is. So here the outer rail is raised to a height h with respect to the inner rail. The inner rail, okay, the outer rail is raised to a height h with respect to the inner rail. Okay, so then it has to negotiate a curve of radius 400 meter. It is moving with a speed of v that is 12 meter per second. Okay, so therefore here there will be a normal reaction, and 2, this is on the inner rail, the normal reaction is n1. So then can say that it should not topple. So mg is acting like this downwards. This length is uh, this length is 1.5 meters. Actually, what is happening? This is the inner rail, this is the outer rail. This length is 1.5 meters. This is height h, and this is mg. This is n2. This is n1. And obviously, frictional forces are acting. Frictional forces are acting on the wheels F1 and F2. And then the centripetal force is towards the center. Okay. Here, what is happening? This torque should be balanced. So about this point, the torque should be balanced. So we can say that N1 into 1.5 by 2, that should, it is the anticlockwise torque, that should be equal to the clockwise torque. That should be equal to N2 into 1.5 by 2. So it means that N1 should be equal to N2. N1 should be equal to N2, and now here, so actually here there is some problem. Okay, so here actually um, here actually there is, we have to assume that there is no friction. We have to assume that there is no friction. So here, suppose any object is moving in a banked road, then it means it is moving with a velocity v. Then uh, this is this will be a normal reaction. This, if this angle of banking is theta, and this is the height h to with which the outer rail is raised with respect to the inner rail. Here actually what is happening, here what is happening, the outer rail is raised with respect to the inner rail. Okay, this is height h, and this is uh, okay. So the rails are 1.5 meter apart. This is the angle theta, then it is moving with a velocity v. This is the normal reaction. There is no friction. We have to assume that, since it is not told anything. So this is mg, and this way it will be n, this will be theta, so this will be n cos theta, angle theta, so this will be theta, this will be 90 minus theta. Okay. So this way it will be n sin theta. So from here you can say n cos theta will be equal to mg and n sin theta will be equal to mv square by r, where r is the radius of the curve. So then we can say that tan theta, that will be equal to v square by rg. So therefore tan theta, from here tan theta we can say this is equal to h by 1.5. So therefore h by 1.5, that is equal to v square by rg. Now therefore the height, that will be equal to v square, v is 12, 12 into 12 by r into 1.5 by rg. R is 400 meter into g is 10. So this will be 4 3 is that 12 into 12. Okay. So this will be 12 5 is the 60, 12 1 is the 12. Okay, 2 6 is the 12, 6 is the 18, 18 into 3 by 1000. So this will be v square by rg into 1.5. So 3 18 3 is a 54. It's 54 by 1000. This much meter it will come. So you have to convert into centimeters. So this will be 54 by 10 centimeters. That is 5.4 centimeters. So 5.4 centimeter is the required height. So option B is the correct answer. Then here it is told a particle is moving in a circle of radius 50 centimeter in such a way that at any instant the normal and tangential components of its acceleration are equal. So its tangential acceleration, that is equal to r alpha, where alpha is equal to d omega by dt, the rate of change of angular speed, and AC is the normal component, which is the centripetal acceleration, which is v square by r. And then it is told that, so it is told that AC, that is equal to AT at any instant, at any time, at any time t. Then if its speed at t equal to 0, at t equal to 0, if the velocity, that is 4 meter per second, the time taken to complete the first revolution will be, the time taken to complete the first revolution, that will be, let's say t1, I call it, that will be equal to 1 by alpha into 1 minus e power minus 2 pi seconds, where alpha will be how much? So here we can call it as alpha dash, which is angular acceleration. So now AC, that is equal to, I can say this is omega square r. Centripetal acceleration is omega square r, and which is equal, and tangential acceleration is r into d omega by dt. So now therefore you can say r d omega by dt, that is equal to omega square r at any instant. So r will cancel, then we can say d omega by omega square, that will be equal to dt. The time t equal to 0, the first revolution it will complete. Okay. So from here, actually, we can see centripetal acceleration is dv square by r, and tangential acceleration is mod of dv by dt, you can say mod of dv by dt. So it means dv by mm, dt, that will be same as v square by r. So therefore we can say dv by v square, that will be equal to dt by r. Now then we can integrate from 0 to v, from 0 to t. So then we will get, this will be minus 1 by v, minus 1 by v, and at t equal to 0, the velocity is 4. So this will integrate from 4 to v, that is equal to t by r. So it means that it will be 1 by v minus 1 by 4, that is equal to minus t by r. So therefore, you can say that 1 by v, that is equal to 1 by 4 minus t by r. Therefore, 1 by v, that will be equal to, this is 4r and this is r minus t. The radius is the radius is half meter. The radius is 50 centimeter, means it is half meter only. So therefore, we can say this will be actually, this way I can say this will be minus 2t. Therefore, 1 by v, that is equal to 1 by 4 minus 2t. So therefore, 1 by v, that will be equal to 4, and this will be 1 minus 8t. So v will be equal to 4 by 8, 1 minus 8t. So v again, that will be dx by dt. ds by dt, we can say that is equal to 4 by 1 minus 8t. Then ds, that will be equal to 4 by 1 minus 8t into dt. Then we have to integrate both sides from 0 to t, and this is from 0 to s. So this will be s, that will be equal to, this will be equal to 4 by minus 8 into ln 1 minus 8t. That will go from 0 to t. So this will be, s will be equal to minus 1 by 2 ln 1 minus 8t, since ln 1 is 0. So now therefore, uh, at time t1, time t equal to t1, the distance covered, that will be equal to 2 pi r. 2 pi r, that is equal to 2 pi into 1 by 2, that is pi. So therefore pi, that will be equal to minus 1 by 2 into ln 1 minus 8 into t1. So therefore you can say that ln 1 minus 8t, that will be equal to minus 2 pi. Therefore 1 minus 8t, that is equal to e power minus 2 pi. t1 actually, okay. So therefore 8t1 will be equal to 1 minus e power minus 2 pi. So therefore t1, that will be equal to 1 by 8 into 1 minus e power minus 2 pi seconds. So therefore alpha will be equal to 8. Alpha will be equal to 8. So 8 is the answer.